parent math interactions in the context of storybook reading. So the first thing is to sort of establish why focus on early parent-child math interactions. And essentially, we know that the quantity and quality and diversity of the kind of math talk children or parents do and engage their children in preschool is predictive of their early math knowledge, which in turn is predictive of their later math achievement, which is in turn predictive of a host of life outcomes, including SES level, high school graduation attainment, entry into STEM fields, and so on. So then the question becomes, if you're interested in early math, why choose storybooks as the context for promoting early child math interactions? And I think the answer to that is because storybooks have a lot of advantages. One, they are highly available to parents, much more so than toys and other math-related games in homes. Parents report reading to their children on almost a daily basis, at least in the US, and so there's a lot of frequency in which they engage in this context. Parents also report being more comfortable in the context of helping and supporting their children around literacy than they do in math, so we can leverage that and lean into parents' comfort with books for math learning. And books also provide an important context, anchor math concepts in more sort of familiar real life situations, whereas very often parents try to address math in the context of very abstract, rote kinds of ways. And so this provides a natural context as well. And in fact, there is quite a bit of research suggesting that there is a value for using storybooks to promote math learning. When you look at experimental studies and intervention work that has compared the use of storybooks that are math related or no math books to unrelated math books, and it promotes greater improvement in children's math skills. And this has been shown both in classroom as well as home-based studies. It also leads children to express greater interest in and engagement with math. And importantly, for the context of this talk, math-related storybooks compared to no books or not math books actually lead to greater, and they elicit greater amounts of adult math talk, both amongst teachers in classrooms as well as parents in home contexts. But I think it's important to note that not all books are necessarily equal, right? So there have been some studies that shown that books that are explicitly math related will elicit more math talk than books that are not math related. I think it seems pretty intuitive, so not surprising. But even if we compare within math books, if we look at counting books, for example, books that display and represent larger sets of items or objects tend to lead to more advanced math talk, like comparative talk, than books that only represent small sets under 5. They tend to lead to very sort of simple counting and cardinality. And there are likely many other features that matter in terms of promoting math interactions, but relatively little empirical work that has systematically tested the value of different features. So in thinking about how that might make a difference, we leaned into some of our earlier work that showed very small differences in materials can have a very large impact on parent talk. So in this particular study, what we did was we manipulated the kinds of play materials that parents interacted with their children. So there was a set of fruits and vegetables, and typically these are set up so that there's unique objects, which makes sense from a literacy perspective. You want them to be able to use as much vocabulary, name as many different fruits and vegetables as possible. But we hypothesized that when you have unique objects like this, it doesn't allow you to think in terms of sets or counting because there's only one of each. So we took the same fruits and vegetables, and the only thing we manipulated was whether it was in homogeneous sets. So still the same number of fruits and vegetables, but now instead of 15 unique, there was 2 apples and 3 pears. So there were sets that could be used. And then the third condition was homogeneous sets of bounded range. So here we hypothesized that using the exact same materials where there's sets, But if you impose a rule on the play where you can, you're making a party platter to pretending you're having a party and making a party platter, but you can't use more than 10 fruits or vegetables, it would force more comparison. Right now they have to think about, oh, I already have 8. How many more can I have? And so it's comparison and arithmetic. And what we found indeed was that these condition differences led to significantly different kinds and amount of talk. So the unique objects unbounded range, as predicted, led to the least amount of math talk, whereas the bounded range led to the most, because now it allowed not only for counting cardinality, but also arithmetic operations, comparison, and so forth. So very subtle manipulation just in the features of the materials and the rules imposed had these big significant impacts on parent talk. And this was guided by the cognitive alignment framework that was first proposed by Laski and Sigler, with the idea that if you really think about designing instructional materials by starting first with what your desired mental representation or behavior should be, and then do a kind of work backwards planning from there, you're more likely to promote engagement and learning. So the idea is first you identify what the behavior should be. And in this case, we want more parent talk and particular kinds of more sophisticated parent talk and a greater diversity of parent talk. And then you would instantiate materials that have that kind of properties in them. If you want math talk, the materials should have math concepts. In the original study, we were trying to promote number line understandings. And so we developed a math game that had linear properties that could support base 10 reasoning. And then you think not only about the instantiation of the features of materials, but what other rules or didactic statements might promote the kinds of processing that you want. And in this case, for the present study line of work, it's really getting children to engage in math conversations more deeply. And when these things are aligned, it should lead to greater learning and those desired representations and behavior. And this general framework has been found to be predictive of the kinds of materials that are going to be most efficacious in a range of math domains. So it's been found to be predictive of what kinds of patterning instruction is most likely to elicit improvement in patterning, what kinds of board games are most likely to promote number learning, what kinds of counting materials are most likely to elicit counting materials, or counting, advanced counting. So guided by this framework, we decided to think about what features in storybooks might matter and might make a difference. And in looking at the literacy work and the transactional framework in literacy, 2 aspects of storybooks have been identified as being really important for engaging children in the storybook context. One is the affordances of the illustration, and the other is the affordances of the text. And each have some literature that supports the ways that they promote engagement. So in terms of illustrations, there's been literature that suggests that when parents engage in shared storybook reading, they most often label and comment and ask questions about the illustrations themselves, and not so much about the text. There's also eye tracking studies that show that preschoolers spend about 95% of the time during shared storybook reading with their attention on the illustrations, and they tend to ask more questions related to the illustrations than the text. On the other hand, there's some work showing that the text itself can be a really important springboard for parents' extra-textual discussion, that it serves to prime them to sort of think about relevant comments that they might want to talk about. So this led us to identify 2 potentially alternative hypotheses about how these features of the book might operate to promote parent math-child interactions. One is that there might be an anchoring effect, where if math concepts are embedded in the illustrations, that would serve to anchor children's attention, to anchor parents' talk. And so it can provide not only an attentional pull toward the math concepts that are embedded in the book, but also an anchor in framing that in a conceptual way. An alternative hypothesis would be that it's the text that matters more, that there's this priming effect in the text, that when readers come across a particular math word or token or concept explicitly present in the text, it activates their math concepts and gets them to not only talk more about that math concept, but others that are sort of embedded in the same semantic network. So to look at these and test these alternative hypotheses, we randomly assigned parent-child dyads to one of two conditions. So we had 50 parent-child dyads. They had to be comfortable reading in English, and the mean age of children was about 4 years. And most of the parents were mothers, and in this sample, they were mostly highly educated. What we did is we mailed 2 versions of the storybook, we'll have to explain in just a minute, to parents. This happened over COVID, so they were mailed the books. They were told not to open the books until the researcher got on Zoom with them. Then they opened the books in front of the researcher, and the researcher turned off her camera, and we just video recorded the parent and the child interacting and reading this book together. The only thing that they were told was to read the book as you would normally read to your child. They weren't told anything about it being a math study, or not told explicitly that math is important or to do math. So what we were looking at is just how these features spontaneously evoke and elicit different math talk. So the 2 conditions were an implicit versus an explicit condition. The conditions were exactly the same in that math concepts were embedded in the illustrations, and it was the same math concepts. The story was about 2 children who were preparing for a New Year's Eve party. So the story was not explicitly math related, although it offered many opportunities to engage in math as they, rode the elevator up to the 7th floor or put their toys on the shelf. In the implicit condition, the text didn't mention anything about the math concepts or skills embedded on the page. So here you see 2 characters, they have shapes on their shirts, and in the implicit condition, it just said they quickly got dressed and they both put on their favorite t-shirts. In the explicit condition, the only difference was exchanging some of the words for explicit math terms. So here, they put on their t-shirts with different shapes, right? Similarly, on this page, that was about counting and cardinality. The implicit condition would say they put teddy bears, cars, and all their favorite toys on the shelf, whereas the explicit explicitly said Sibby put 2 teddy bears and 4 cars on the middle shelf. So explicitly had numbers. The text complexity, everything else was held constant across the 2 books. Then after parent and children read the book, we coded the different kinds of math talk that they used. We coded for 2 big categories of math talk, different instances of number talk, including references to counting or cardinality or identifying numerals, and different instances of spatial talk, including identifying shapes or patterns or the spatial positions of objects on the page. Then we calculated 2 measures: the amount of extra textual math talk. So you don't get extra credit for being an explicit condition in reading the book. Right? It has to be talk above and beyond what was in the book. And for the diversity of that talk, how many different kinds of talk you used over the course of this 15-minute interaction. And what we found was that both for number talk and spatial talk, parents in the explicit condition use significantly more talk, their greater amounts of talk. We also ran this controlling for total amount of talk. So we wanted to make sure that it wasn't just some parents. We had, our random assignment didn't work, and explicit condition parents were just more talkative for some reason. So even controlling for total amount of talk, we still see the significant condition effect. We also see a condition effect for the diversity of math talk, where not only did parents in the explicit condition generate more talk, but they generated more kinds of talk, which we know is really predictive of children's learning as well. So from this, we can conclude that there seemed to be more evidence of the priming hypothesis, that having the explicit math tokens embedded in the text primed parents, not just to read what was there, but to talk more about other related math concepts, right? I do think it's important to note, though, that it wasn't quite a comparison of illustration only versus text only, right? It's more a comparison of illustration plus text. So I think a follow-up study needs to be if we want to isolate the effect of just having it in text. Although that seems counter to sort of ecological validity. Most books wouldn't just have it in the text and not also for this age group illustrated in the picture. But another important thing to think about is if we're talking about storybooks is to go back and relate it to books themselves. Are any of you aware of this book, Zoom? Wordless storybook where you zoom in and out of illustrations. And thinking about this book made me think about how zooming in to a particular feature might make us actually lose sight of other things that matter, right? So it was possible that this broad categorization of a general book feature, sort of illustrations versus text, might not have allowed us to identify sort of more nuanced contributions of individual book pages and individual features of the illustrations versus the text. It also seemed possible that a focus on just one aspect of math talk, just number talk, might have obscured other important aspects around the interaction. For example, whether parents were more inclined to make statements or to ask questions and prompt children. So then we took that same data and we looked at it more deeply. And this work is still in progress. It's a little more exploratory. But what we wanted to do was, rather than averaging across the entire book and the entire interaction, was to see if there were differences page by page. So in a way, a kind of what we would call a microgenetic analysis, where we're doing a trial by trial analysis. And so we coded, or we graphed, the mean number of utterances on each page. And what we found was that there were big peaks and valleys. Some pages tended to elicit much more talk than other pages. And so we then did a more careful analysis of what features those pages had, like what was particularly special about those pages. And we generated 4 potentially relevant features that varied across pages. Right? So one was the interplay between illustrations and text. There were some times in some pages where the text and the illustrations were almost redundant, right? The text said exactly what was already immediately observable in the illustrations. Put 4 bears on the shelf and there's 4 bears. There were other pages on which the illustrations offered more information. So one example of this was a page where they go shopping and City borrows some money to buy cupcakes. And you don't know why you had to borrow money unless you check the illustrations for the price tags on the items, and then you can do the calculations. So together, they offered more affordances. Another feature was the number of math concepts. Some pages only addressed one math concept embedded on them. Other pages actually had multiple math concepts. There was also a difference in the type of math construct that was embedded in particular pages. Sometimes it was a very procedural construct, like count how many toys on the shelf, and other times it was a more conceptual construct, like doing some arithmetic or problem-solving operation. And then the amount of text varied as well. There were some pages with less or greater text. I do think it's important to note that because this was in some ways a post-hoc analysis, we identified these features as varying across the pages of our book, but in this work, we had not systematically varied these features. And so that's important to say. But for each of these features, we dichotomized how these features might play out and which aspect or continuum of the feature would lead to more versus less talk. So in terms of the interplay between illustration and text, we hypothesized that when the illustrations offer more affordances than the text, you would see greater amounts of math talk because there's more to anchor the math talk, perhaps because the text doesn't explicate it enough, so the parent feels compelled to try to explain and elaborate for the child using the illustrations. than when the affordances are basically the same. So here it's 10 o'clock, and all you have to do is look at the clock, and it's just a confirmatory sort of approach. It's completely redundant. In terms of the number of math concepts, we expected that multiple concepts would lead to a greater amount of math talk than one. And this actually we went back and forth on, so we can push challenge me on it, because at first we thought, well, maybe if there's just one concept, you talk more about it more deeply, whereas if there's multiple, you feel rushed and it's shallow. But on the other hand, if there's multiple concepts, it gives parents more leeway to target the ones that might be of more of interest or at the right level for their individual child. So it could elicit more talk in that way.
So what would count as multiple concepts?
So here, for example, it says their mom bought 4 apples, 3 bananas, right? So the affordances on this page are counting the sets of apples. You can do counting and cardinality. There's also the price tag, so they could do numeral recognition. There's also the possible affordance of adding, how much do they pay when they have apples and bananas. So it's multiple potential concepts that a parent could talk about. Where on this page, it says, look at the numbers 2021 are in the sky. It's essentially just a numeral identification, and there's not really much more you could talk about. In terms of the type of math concept, we predicted that pages that engage reasoning and problem solving would elicit more math talk than pages that are simply procedural. So the distinction here would be, on this page, it says, after breakfast, Waggy and Sibby played with blocks. Waggy looked at Sibby's tower and said, your tower is taller than mine, but I use more blocks. Not exactly clear how those two concepts relate to each other, right? And so it involves some problem solving. Whereas here it says, push the number 4 to get to the second floor. Very procedural, find the number 4, identify it, and that's that. And then finally, in terms of amount of text, what we did, because we had not a priori prepared for this, is we just took the amount of text in the book and did a median split. And so we categorized pages that had, the median was 40, pages that had less than 40, we categorized as low text. Those that had more than 40, we categorized as high text. Okay? And we predicted that low text would lead to greater amount of math talk because you don't get so overwhelmed in the storyline, and the math concepts might be more stale. And so what we did is we went back to the data that we already had from the previous study. And in this case, we only analyzed the data who were in the explicit condition, because it was only in that condition where there was the text illustration affordances feature. And we coded each page, giving each page an individual feature score. So for each feature, we gave it either a 0 if it represented sort of what we thought was less likely to be promoted, and a 1 if it represented what we thought was most likely to be promoted. And then in addition, each page was assigned a total feature score. So anywhere between 0 and 4, we just summed up the values for the different features. And then from this, we generated 3 different kinds of math talk measures. Again, we just looked at the sheer amount of math talk, but this time we also coded the frequency of math questions, because math questions have been found to elicit more thinking and engagement than simply statements. And then for math questions, we coded whether they were high cognitive demanding, sort of really engaging problem solving from the child, or if they were simple kind of yes, no responses.
So these are math questions that parents ask.
Yes, all of this we coded only for parent talk in this study. Yeah. And what we found was the predictions that we expected, meaning that the promotive features predicted parent math talk. For all the promotive features predicted a greater amount of math talk and a greater amount of math questions. The only thing that didn't play out as predicted was that multiple concepts didn't necessarily generate or elicit more high cognitive demand questions. We also saw an additive value of the promotive math features. So pages that had a greater number of these promotive features elicited more of all 3 kinds of math talk, with it having the greatest contribution to math So in terms of sort of the findings that we concluded from this is that features do matter, and we identified some features that would be interesting to pursue in future work. But again, because we didn't systematically vary them, there are some confounds. And so I think future work could really explore and tease these apart, holding all else constant, just what is the value of the illustration text affordances compared against the value of, for example, having multiple concepts. Also the case now that we might have gone, so narrow and zoomed in so much that by narrowly coding and quantitatively just checking the frequency of math talk and questions, that we might have obscured more interactive effects that happen with the child. So parents aren't alone in these didactic interactions, right? These math-child interactions are happening in concert. And so it could have obscured not only other ways beyond math talk and questions that parents engage children in math, but it could have obscured the evocative effects that children have themselves that are separate from the book or interacting with the features of the book. So to explore this, we used again the same data, now from across both conditions, and we looked at dyads that had produced greater than 10 math utterances. So we had enough of a corpus of math talk to work with. And then we applied a qualitative analysis often used in linguistic literature known as conversation analysis. And conversation analysis is guided by the theory that conversation is a two-way, it's co-constructed by both speakers, and that you can see sort of bounded math utterances. So what we did was we looked at a particular kind of math utterance known as initiation response evaluation. So when a parent initiates some sort of conversation with a child, how that interaction proceeds, and then how the parent closes that interaction. Okay. Then we also, rather than just quantitatively coding, we looked at paralinguistic features. So we paid more attention now to things like the parent's intonation, to their speed, to their gaze, to their use of gesture. Okay? And then we did some unmotivated looking. So while we had research questions in mind, we really wanted to see what themes emerged from the data themselves. And what we found was that parents used a really wide range of ways to initiate math conversations. Okay? And notably, one approach that emerged did not involve the use of number words at all. So for example, and these are known as appender questions, where you ask a question simply by leaving a blank. So here, for example, on this page, the mother says the next stop was the grocery store. She's reading the text. Then she says, their mom bought. The child responds for. The mother ends by saying apples. So in our quantitative coding of number tokens and words, this would not have been captured at all. Yeah, but very clearly, the mother is purposely and intentionally eliciting a math conversation with her child. We often saw that parents' talk was simply meant to confirm or reiterate the numerical information in the text. So this gives us some more insights into why explicitly embedding the math tokens in the text itself might have promoted more math talk. The parent reads the text, and then she asks for confirmation. So how many strawberries does Sibby have? Having already identified it. And then we identified these use of proposals, which are different than sort of questions where the parent only says, how many apples are there, right? That have a sort of a right or wrong response. Proposals are more of an invitation to work collaboratively. So here, for example, the parent reads the book, Sibby put 1, 2 teddy bears on her shelf, and do you think you can count the cars with me? Let's try it one more time. And what we found is that these question frames led to the longest conversation turns, the most cooperation and scaffolding that occurred between parent and child. Now, this is noteworthy because many of the previous interventions that have embedded questions for parents to ask don't tend to use these frames. They tend to use much more sort of explicit, how many are they on the page kinds of frames. And then while most of Parent Talk was initiated with the text itself, we found that children's attention to the illustration did have evocative effects. So often it was the child who would notice something in the illustrations themselves that would then evoke the parent. So here the child saying, okay, so this only has 3 strawberries on each side. This one has 4. And then the parent confirms by saying, yes, so this one did 3 and 3, and this one did 2 and 4. And it's hard to know if that interaction would have occurred simply spontaneously from the parent, but it gives us some evidence that children are anchoring in the illustration and the value of pairing these 2 features together. And then the last is that sort of the mathematically ambiguous text did seem to elicit the more cognitively demanding questions. So this was the page I referred to earlier, where it's not quite clear why hers is taller, even though that she has more blocks, right? It's ambiguous, and it sort of required the parent to sort of lean in maybe and make sure that the child was following along and doing some math comprehension. And so it elicited these reasoning, high cognitive demanding questions. Most of the commercially available math books for young children at this age are very simple counting books. So they don't have this kind of mathematical ambiguity. There's always a direct correlation between the text on the page and the illustration. So in summary, we think that this line of work shows that Parent Talk can be affected via the features or the affordances of books, and importantly, without any additional training or prompts. So again, most of the parent-child intervention work has focused on having pretty intense trainings with parents, espousing the value of math, making them aware of math, giving them explicit things to do and say when they engage with their children in math. Not only is that not scalable, but it also can change, in some other work we've shown that it can change the nature of the interaction. It can make the interaction more didactic, which now has ways of interfering with motivation and engagement. So here we show that we can make the book, the materials themselves, do the work and allow parents to lean into their own spontaneous and natural ways of engaging with children. We also can say that predictions can be made about the instantiations of features that are more or less likely to promote parent math talk. So we can systematically test those as well as design books for those. And that there does appear to be an additive rather than a competitive nature to the value of features. But again, as I said, there's more systematic analysis is needed of these individual features and the comparative value of each. And when that work happens, I think what we've learned from our conversation analysis study is that it's important to think beyond just quantifying a quantitative analysis of the frequency of math utterances and tokens, but thinking in a more qualitative way about the nature of interactions and capturing more of the evocative effects and the back and forth between parents. So I just want to end by thanking my lab members and my collaborators with which this work could not have been done. Thank you.